Okay, physical topology means the physical arrangement of the networks. We discuss about actually a few bus topology, ring topology, star topology already, and we have tree topology to discuss. Right. So today we'll discuss about tree topology, and as well as there's another topology that is called mesh topology. Right. Okay. So please write down the subheading tree topology. And so when you discuss about tree topology is actually combination of two other topologies we have discussed already. Topology means the physical arrangement, how network is arranged kala tiyana vidiya. And we have already discussed bus topology. Can you remember that? What is the arrangement in bus topology? Yes, bus topology arrangement එක මතකද? We have central baseline. To central baseline, everything else connected. That is bus topology. We had central baseline, and to that, everything is connected. And tree topology is based on two other topologies. It is based on star and bus topologies. We can see, right, star topology and bus topology together. That means we have central baseline similar to the previous topology. We have the central baseline. To this central baseline cable, to the central baseline cable, there are other cables connected using T connectors, sub cables connected to this central baseline using T connectors. That is the bus topology. You know that. Use T connectors to connect branches, and this is what we can see in the bus topology. Okay, other than that, what we can see is to these T connectors, switches or hubs or concentrators, that also we discussed last day. Switches or hubs or concentrators are connected to these switches, these edges. So here these are the switches. To these switches, we can connect some more computers using star topology. To these switches or hubs, we can connect computers using star topology. Let me draw the computers also. Let's say you have your computers like this. You can connect the computers. You can connect these computers to the switches by creating tree topology. Okay, please draw this. I'll draw a few computers, right? If you want, you can draw more, but anyway, the concept is this. In the concept, you can see this. Computers are connected to the switch. It can be one computer, a mini computer. So actually, internet works according to this model. Internet works according to this model. I'll explain, right? I'll explain and I'll show this practically. Okay, first draw this. This is our connection line from the switch. Let's increase the line size. Let's increase it to 3 points. These are the computers. These computers are connected to the switch. Tree means, I make it a tree. It's like the branches and leaves. Branches and leaves. So it has many branches and leaves. The leaves are the end devices. End user devices are the leaves. Okay, the central bus line is there. Central bus line is created using fiber cable typically because it should be faster. Fiber cables are faster than the other wired technologies. So we are using fiber cables to the central base cable. And you have terminators also. Why terminators are used in bus topology? Netuli, Why terminators are used in bus topology? You have two terminators here. Let's use this. Why terminators are used in bus topology? Any reason? Can you remember that? Last day we discussed, right? Why terminators are used in bus topology? Anyone? Sit me. Reason for connecting terminators? Sit me. Can't remember. Okay, the reason is, right? The reason is to stop signal bouncing, right? To stop signal bounce, because bus topology, you can like send signal. So or any party can send signal. So it should go and stop somewhere. Otherwise, it will like try to bounce and deliver the signal to some end, thinking that it is not over. But these are absorbing the signal and stopping signal bouncing. Okay, please draw that quickly. And also name the components in this topology. So if anyone having doubt, please ask, then I can respond, right? So maybe this is different from what you have learned previously. So in such case, or if you have learned something else in school or somewhere, please let me know. Then I can help you understand this. But to do this, you have to talk. කතා කරලා කිව්වොත් මට පුළුවන් මෙහෙම නෙවෙයිනේ අපි ඉගෙන ගත්තේ මෙහෙම එකක් තියෙනවා නේද pre topology එකේ. Likewise, topology කියන්නේ arrangement එක. This is the arrangement that we can see. Okay, under that you can write, after drawing, you can write, you have to name the component. This is the central baseline. And to central baseline, you have terminators. And you have T connectors also. T connectors. And switches. And then computers or nodes. Okay, please draw some arrows to indicate that T connectors are in the junctions, and central baseline cable is this one. This is the central baseline cable. Terminators are at the end. Terminators, you can see those at the end. There are two terminators basically. Then you have switches. Switches are distributing the connection, repeating the connection to the computers. It's actually like amplifier. It's getting the signal, amplify and deliver to the network. And nodes are the actual connected computers or the computing devices. I hope you're still drawing this, right? After drawing, you can write down the small part. It's based on star and bus topologies. Baseline is implemented using high-speed fiber cables. And it is distributing the common and main traffic. Common and main traffic. Switches can be used to expand the branches. switches can be used to expand branches, and nodes will get the service through switches. Nodes will get the service through switches. That is what happening. And anyway, you can, so I couldn't draw here. So if you want to further expand that, so it is possible to use, if you want, you can draw that as well. So if you want to further expand this, you can use some more switches, right? From switch also, you can connect to some other switch. So that is the nature. From this switch also, you can connect to some other switch. That is possible. If you connect like that, from this switch also, you can connect computers. Even mobile phones, computers, anything you can connect to this switch. A mobile phone, a laptop, a computer. Using switch also, you can further expand this. So that is the nature of tree topology. You can expand. Main idea of tree topology, then tree එකක් ගහක් හැදුනම බලන්න. So it can expand, right? ඒකේ lifetime එකේම ජීවිත කාලෙම ඒකට develop වෙවි expand වෙන්න පුළුවන්. That is possible. So that feature is there in the tree topology. It's possible to expand. Okay, can you tell me the advantages and disadvantages? You can easily tell, because in previous day we discussed about we have discussed about bus topology and star topology. You know the advantages and disadvantages of both. So those are the advantages and disadvantages of tree topology. Yes. So what are the advantages? Okay, I'll give you some time to write down if you're still writing down. Do you need more time to write? Anyone else is writing? Please raise your hand. I can give more time, right? If somebody is writing, please raise your hand. I can give more time. Can you raise the hand? No one is writing. I think I'm in English medium class, right? No need to translate and tell everything. Those who finished writing, can you raise your hand? Okay, come on. Okay, only one. Sit me, finished writing. Okay, 5, 4. Okay, I assume that you finished. Okay, now tell me, so what are the advantages of tree topology? It can be expanded, right? Can be expanded. It can be expanded easily. That is the main thing. Flexible. You can, anytime you can put a machine, add in and remove in. Computers will not disturb the current operations. In the network. Those are the advantages. And disadvantages. If baseline fails, the entire network will go offline. The entire network will go offline if baseline fails. And it is difficult to troubleshoot. that is related to baseline and infrastructure. But it's not difficult to troubleshoot, especially it's difficult to troubleshoot for baseline and infrastructure. It is difficult, but not for the computers, right? Individual computers, it is easy. Right, okay, put asterisk and write down a special point. Internet users tree topology. Internet users tree topology. Internet users tree topology. Okay, I'll ask one more question. This is from your general knowledge. How we get wired internet? What is the baseline? Okay, can you tell? Can anyone tell how we get wired internet? What is the baseline for wired internet? How Sri Lanka gets wired internet? What is the baseline? Yes? You all are so silent. Either you are writing down or maybe. So have I muted my microphones? Speakers? No. Sit me, how we get internet? Sachini?
Fiber optic.
Yeah, fiber. What is the fiber cable? So we are getting through a fiber baseline. What is the cable name? That cable name is called CMIEEE. Right? That cable name is called CMIEEE. Actually, that is connecting South, East Asia, Middle East, and Western Europe. It's connecting Southeast Asia, Middle East, and Western Europe. That is the bus cable, that is the baseline cable that we are getting internet. So you can go to Google and type CMIEEE. Right now, actually, we are using CMIEEE 5, CMIEEE 5, 6, those versions. And basically, because initially it was CMIEEE version 1, but now there are some extensions, right? So, okay, let's say this is CMIEEE 3. So different versions you can see. This is CMIEEE 3. In Wikipedia, you can see all these versions and the central fiber line and the extensions. These are the T junctions or the extensions from this. This is CMIEEE cable. It's a wide one, right? It's connecting continents, intercontinental cable. Right. So this is CMIEEE 5 cable. CMIEEE 5 cable. So basically connecting France, Italy, Egypt, Saudi Arabia, Yemen, and Pakistan, UAE, Dubai, Oman, India, Sri Lanka, and Bangkok, Myanmar. It's going up to Singapore. We are getting the connection here. Right? So if you need further details, this won't be asked in the examination to draw a map and mark CMIEEE cable, but you should know this is a submarine cable going under sea, right? One time this got damaged. Ekaparak mega damage juna. So due to some ship failure, there was a damage to the CMIEEE cable and we lost internet for some time, wired internet. But still we have now wireless internet connections are coming to satellite. That facility is there. Right? We have wireless internet facility. And actually, due to this CMIEEE, due to this CMIEEE cable, so due to these connections, so we can get like faster internet connections. This is a fiber cable. This is a fiber cable. And so actually, this is like central baseline, the bus topology. So implementing bus topology, central baseline through the CMIEEE cable. Right? So this is CMIEEE 5. We are connected to CMIEEE 5, and then actually our providers like SLT and Dialog, all these people, they actually connect to their switches, and through their switches they are distributing to the next place. And from that, actually, the companies and people are using some other switches. So it's like leaves, right? Trunk. This is the trunk. From the trunk, you get some branch. From the branch, you get leaves. So sub branches. From the sub branches, sub branches. From the sub branches, sub branches, and that's how it comes to our home. Fiber to home. It's fiber link. So if you can get fiber to home connections fast, because so the full length, the connection is using fiber. It's coming from fiber and delivered to you in fiber. It's costly, but fast. But if you're using copper cables, so in the middle, it's changing, right? It's changing to the twisted pair and copper cables. Okay, so now you know how internet is. Okay, hope you finished writing, right? Anyone else need writing time? Writing advantages, disadvantages, anything, right? Okay, done. Okay, so this is the tree topology. The advantage of tree topology is expandability. It's highly expandable. So please remember, it's highly expandable. It's expandability. Expandability is the advantage. If you use star topology, so you need individual wires to each location, right? Star topology waladi, හැම එකනටම තනි wire එකක් දෙන්න ඕන physical. So let's say your distribution center is Saudi Arabia. If you are using star topology, there's a wire for UAE, there's a wire for Oman, wire for Pakistan, wire for India, wire for Sri Lanka, wire for Bangladesh, Myanmar, likewise. Each and every continent, subcontinent should get a wire. That is costly. Can't implement internet in such a way. So it's costly, right? Heavy, because these fiber cables, you know, it's thousands kilometer long cables and protection methods. So it is protected highly, right? So it's a high traffic protected. And because of that, these cables are costly. So you can't have individual link. But having branches is okay, right? Having branches somewhat okay. Okay, then so then you can't have a ring topology because even world is like a ring. So it's difficult to have due to obstacles and some continents, some physical, that it's no point in cabling like the sea. If you just drag cables through the sea, it's no point. So ring topology is useless here. Only topology works here is bus topology. But if you use only bus topology, how to connect? හැමෝටම T connect එකක් ගහගන්න වෙයි මේකට connect වෙන්න. ඒක කරන්න බෑ. Therefore, so which is taken from the bus topology is distributed using star topology like this. So this is maybe SLT. This is fiber to home connection. Right? Maybe this is your SLT router. From SLT router is going to your school router. From the school router, you're getting the connection. Something else. Okay, then the last topology, last physical topology is mesh topology. Do you have a question to ask about the star topology? Sorry, tree topology? Okay, then write mesh topology. Mesh topology. Mesh කියන්නේ දැලක්. මේ topology එක දැලක් වගේම තමයි. Mesh එක. Aim of the mesh topology is to create a false tolerance network. Aim of the mesh topology is to create a false tolerance network. In mesh topology, nodes are connected directly to other nodes, to other nodes. Nodes are connected directly to the other node, to other nodes. One node may have more than one connection paths. One node may have more than one connected path. Okay, under that, write fully connected mesh. Fully connected mesh. In fully connected mesh, let's say you have 3 nodes. In fully connected mesh, let's think that you have 3 nodes. 1, 2, 3 nodes. And let's say these are the computers or the nodes. Node number 1, node number 2 and 3. If you have 3 nodes, how many cables you need to connect each node to each other node? How many cables? Yes. I'll ask from Satira. How many cables you need to connect each computer to each other computer? I'm a computer. Computer.
3.
Yes, you need 3. Correct. In the fully connected mesh, you need 3 cables to connect. This is cable number 1 and cable number 2. Cable number 3. In fully connected mesh, you need at least 3 cables. Okay, let's enhance the number of computers to 4. Now, how many cables you need? You have enhanced this to 4. Is 3 enough, or do you need some other cables? Satira? How many cables you need now? You have to connect each computer to each other computer.
1.
1 cable enough? Okay, if you have 1 cable, I can connect like this. I can connect only to 1 computer. But that is not the idea of fully connected mesh.
3.
Yes, you need 3. You need 3. This need to be connected to this cable and need to be connected to this machine too. So altogether, how many cables? You can see altogether 1, 2, 3, 4, 5, 6 needed. Okay. Number of cables you need when there are when there are 6 PCs. Can you tell the number of cables you need when there are 6 PCs? Also the number of cables you need when there are 8 PCs. Can you tell the answers for this one and the second one? In the fully connected mesh, how many cables you need if it is 6? How many cables you need if it is 8? Yes? Cable kiye gane onada? PC hayak tibbo. Four computers need 6 cables. 6 computers. How many cables? Every computer should be connected to every other computer. That is the logic. Every computer should be connected to every other computer. What if number is 6 and what if number is 8?
16 for 6 PCs.
15 for 6 PC.
No, sir, 16 cables.
Then for 8? You can draw and do this, right? Okay, let's draw one.
64.
64. Okay, how? Right, when you need 5 computers, okay, now already there are 6. When you need 5 computers, you need another 4, right? You need another 4. Because to connect this, you need 1. And to connect this, you need another 1. This is what mesh is. Mesh is a mess. You need another one to connect this one. And you need another one to connect this one. So altogether, how many cables? Earlier it was 6. Sorry, 6 plus 4. Now another 6 plus another 4 came. If 5 computers, it is 10. Okay, the 6th one came. You need another 1, 2, 3, 4, 5. So total will be 15. And 7th one came. You need another 6 to connect the. When 6th one, 15. 7th one came. You need another 6. That is 21. When the 8th one came, you need another 7, 28. Okay, how this is found? It is like triangular number, right? Triangular numbers. Trikona සංඛ්‍යා නේද එන්නේ. එකක් තිබ්බොත් ඉතින් කාටවත් කනෙක්ට් කරන්න දෙයක් නැහැ 0. දෙකක් තිබ්බොත් එක කේබල් එකක් ඕන. First triangular number is 3. තුනක් තිබ්බොත් 1 plus 2. තුනක් ඕන. හතරක් තිබ්බොත් 1 plus 2 plus 3. හයක් ඕන. පහක් තිබ්බොත් if you have 5, it's 1 plus 2 plus 3 plus 4. You need 10. If you have 6, 1 plus 2 plus 3 plus 4 plus 5 plus 5. Then you need 1 plus 2 is 3, 3 plus 3 is 6, 6, 4, 15 for 6. 7, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus, you need 6 for 7, 21. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 for 8 lines. Altogether for 8, 6. 6 plus 6 is 6 plus 4 is 10, and 10 plus 5 is 15, 21, 28. Right? This is how you calculate the number of cables. So there's an easy way of doing that. You can say n into, yes, n into n minus 1 divided by 2. Is it correct? If you have, okay, if you have like n number of pieces, 5 pieces, 5 into 5 minus 1 is 4 divided by 2. 4 divided by 2 is 2. 2 into 5 is 10. Correct, right? 5 pieces, 1 plus 2 plus 6 pieces. 6 into 6 minus 1 divided by 2. 6 into 6 minus 1 divided by 2. 6 minus 1 is 5. 6 into 5, 30. 30 divided by 2 is 50. So that is the equation, right? Triangular number equation. N into n minus 1 divided by 2. Okay, this is how you can find the number of cables that you need in mesh topology. Please write down this. It is triangular number. So 2 PCs and 3 PCs. Likewise, you can just enhance the number of PCs and tell the value. So please write down quickly and show this how to calculate. And you can say n number of PCs. Then it is n into n minus 1 divided by 2. I think you finished writing this, right? Just write this 2 PCs and 3 PCs. 4 PCs, 5 PCs, 6 PCs, 7 PCs, and 8 PCs. So this is how the calculation happens. If you disconnect from the line, please rejoin. So I think you within 2 minutes you'll be disconnected. So please rejoin to the same line. Because the next spell, we are going to discuss the partially connected mesh topology. And also logical topologies like Aloha, CSMS-CA, CSMS-CD. So yes, CSMS, CSMS-CD, CSMS-CD, Aloha, and slaughtered Aloha. So that is what we are going to discuss. And the remaining is only network security. Right, the last part is network security, I believe. And with that, your lesson will be done. That means next week, most probably can finish the lesson. If I didn't miss anything, so please go and look at that. So then I can finish network topology next day. So network lesson next day. And that means we can start our revision after next week. I'll start discussing 2020 paper and going back, right? 2020, then 2019, then 18, then 17, then 16, then after that model papers. If you don't have papers, please download the papers from the internet and prepare. That is one thing, or you can buy a paper book. Either way is recommended. So you can either download, everything is available on the internet now. Finish writing this. Is there anyone writing still? Is there anyone? Umesh, are you writing still?
No, sir.
Right. I then write partially connected mesh.